Okay, in this video we are going to look at this sheet from class. Okay, so you should be reading. I'm going to highlight a few things. Carbon has 4 valence electrons. Here's the Lewis dot structure. You draw it like this. See? Like this. That means it can form 4 bonds. Something can bond right here. Something can bond right here. Something can bond right here. And something can bond right here. Here's an example of a hydrocarbon. It only contains hydrogen and carbon. Okay, so let's review kinds of formulas. Empirical is the lowest whole number ratio. So that means it's reduced, right? Lowest terms. So think lowest terms. For molecular, it's the exact number and kinds of atoms in a formula. So literally, if I look at a molecule of glucose, what's in there? What are the actual elements and what are the actual atoms? And then structural formula is a graphic representation of how the atoms are bonded. It is a diagram of molecular. So if you see structural, you automatically know it's molecular because structural is a diagram of the molecular. And then condensed structural is like a shorthand way to write the structural formula. Okay, so here we can see molecular, empirical, condensed structural, and structural. All right, so let's practice. What is the empirical formula for these compounds? So look at my subscripts 2 and 4. So if the ratio of my atoms is 2 to 4, can I reduce that ratio? Yes, I can, to 1 to 2. So my empirical formula would be N. I don't write the 1, O2. All right, so this ratio is 2 to 1, right? When there's no subscript, it's a 1. So can I reduce that ratio? No, I cannot. So the empirical formula is the same, H2O. Let's look at this ratio, 3 to 6. Can I reduce that? Why, yes, I can. So the empirical formula would be 1 to 2. So that would be CH2 because we don't write the 1. Let's look at the next one. My ratio is 10 to 20. Can we reduce that? Yes. I can divide both of these by 10, right? So that would be 1 to 2. So again, CH2. And then C4H10. So 4 to 10. Can I reduce that? Yep, divide them both by 2. 2 to 5. So C2H5. Right? Now what about over here? Write the molecular formulas based on the following structural formulas. So I just count. And my formula is always in this order. CHO. Do I see C's? Yes. Do I see H's? Yes. Do I see O's? No, I do not. So I'm just going to count those two. So let's count C's. 1, 2, 3, 4, 5, 6, 7, 8. C8. H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. Count it up, that's molecular. So let's look at this one. I always write in the order. CHO. Do I have any C's? Yes. Do I have any H's? Yes. Do I have any O's? Yes. Do I have any other things? No. If I did, they would go next. Okay? Count how many C's. 1, 2, 3. C3. Count how many H's. 1, 2, 3, 4, 5, 6, 7, 8. Count how many O's. 1. I don't write the 1. So there we go. That is the molecular formula, counting what's in the molecule. All right, now we are going to look at this page. You have some reading here to do about alkanes. Alkane is a hydrocarbon. There are only single carbon-carbon bonds. Here are some examples. Notice I have prefixes, right? Notice they all end with ane. That's something they have in common. Where do these prefixes come? We'll see in a second. Okay, so again, they're all alkanes because they have only single carbon-carbon bonds. Remember this, a hydrocarbon only contains carbon and hydrogen, right? We have 3 kinds, but we're going to focus on one today. That's alkanes. All right, so table P, do you see this? This is prefixes. Notice it says this, number of carbon atoms. So you don't have to guess what it's for, okay? Also, just as a note, this is in table Q, which we're not talking about today, but all alkanes end with ANE. So we just take the prefix and then stick on ANE. All right, so what is the name of this hydrocarbon? Well, it's all hydrogens, all carbons. Do I see any double bonds? Nope, I see all single bonds between those carbons. So I name it by counting the number of carbons, 4. What is the prefix for 4? Bute. Add ANE. So this is butane, you know, like in lighters. Okay, what's the name of this one? I see all single bonds, so I know it ends in ANE. I need a prefix in front. What prefix? I need to count the number of carbons in the chain. 1, 2, 3, 4, 5, 6, 7. What is the prefix for 7? Hept. So that is heptane. Hept means 7 carbons in a chain. Ane means they're all single bonds. So I put 7 carbons in a chain and all single bonds. So I fill it with hydrogen. What about this one? So I see only single carbon-carbon bonds. Ane. I need to count the number of carbons in the chain. 1, 2. What prefix means 2? Eth. So this is ethane. So what does this name mean? Eth means 2 carbons. Ane means all single carbon-carbon bonds. So ethane means 2 carbons in a chain and all single bonds. So the rest is filled with hydrogens. Okay, so how would we name this one? Well, I see all single carbon-carbon bonds, so that is ane. I need to count how many carbons are in the chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the prefix for 9? Non. So the name of this is non-ane. What does the name mean? Non means 9 carbons. So I have a chain of 9 carbons. Ane connected with all single bonds and the rest filled with hydrogens. Okay, so let's look at this for a moment. Can you see I have a chain, but then I have something stuck off of the chain? A branch, okay? So when I number this, okay, I have to think about where the branch is, all right? So what I need to do is I need to find the longest chain of carbons, okay? So watch, I have one option, 1, 2, 3. Well, that's a very short chain. So let's see if I can get a bigger number. I could go 1, 2, 3, 4, 5, 6. That's going straight across. That is the easiest way to go. So unless I see a longer chain another way, that's going to be my chain. So let's try it this way. I have 1, 2, 3, 4, 5, 6. Okay. Could go that way, or I could go 1, 2, 3, 4, 5, and then 6. So I have some options, right? Okay. I could also start here, up here, 1, 2, 3, 4, 5, 6. But the biggest number I get to is 6. So if I can't find it another way, it's going to be easiest to count this as my chain. Okay, now that I have my chain, what I need to do is figure out, is there anything that is off the chain? Off the chain, I need a branch. Here we go. This is a branch, right? Do I have any other branches? No, because the rest are hydrogens. Hydrogens don't count as branches, okay? So this branch has to have a special number, because if I just gave you a name, you should be able to draw it. So you should have all the clues to be able to draw it. But in order to do that, you need an address. So where does this live? Okay, what's the address, right? If you live on Delaware, you can't just say, bring it to my house on Delaware. Like where? You can't just say, put that on a carbon. What carbon? So you got to be specific. So since we realize this is our longest chain, we could number the carbons going forward, or we could number them in reverse. If we number them going forward, our branch is on carbon number 2. If we number them in reverse, our branch is on carbon number 5. And the rule for organic chemistry is we got to pick the lowest number. So this is the right numbering, okay? So when we name the whole thing, we have to name the branch and we have to name the chain, the longest chain, okay? So when we name this, how do we name it? We name the chain. What's the chain? 6 carbons, all single bonds between the carbons. 6, do you remember, is hex. Ane is that ending. But we got a group right here, right? So we got to attach that group on, and we'll go through this in greater detail later, but as a quick summary, how many carbons are in that branch? 1, okay? So that is going to be meth. So when we name this later, this name is going to have something to do with meth, and it's going to have something to do with the address of 2. The address is the carbon it's attached to. Okay, one last thing from right here. Do you see this? Look at this one. Do you see how this is a meth attached to carbon number 2? And see how this looks like a different compound, right? It looks like the same, but all it is this compound looking in a mirror. Because this time, instead of numbering forward, I would number in reverse, and the branch is still on carbon number 2. So if the compound can look in a mirror and see itself, just reverse, right? Then is literally the same compound, okay? When you look in the mirror, you don't turn into a different person, right? So this is the same compound. They're just mirror images, okay? Because for both of them, the group, the branch, has an address of 2. Okay. Okay, let's go through this kind of step by step. We're almost there. So here, let's assume that the longest chain goes across like this, and then we're going to check and see if that's not true. 1, 2, 3, 4, 5, 6. So that has 6 carbons. In order for that not to be the longest chain, I would have to find a longer one. So I could go 1, 2, 3. Well, that's shorter. I could go 1, 2, 3, 4, 5, 6. That's the same. 1, 2, 3, 4, 5, 6. That's also the same. So this is my chain, and this is my branch. See how it's off the chain? Okay. So how many carbons are in the longest chain? 6. How many carbons are in the branch? 1. What prefix would you use to describe the longest chain? It had 6. That would be hex. What prefix would you use to describe the branch? It had 1 carbon, meth. Okay. Let's try this one. How many carbons are in the longest chain? So we're going to try the horizontal straight across first. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. In order for this not to be the longest chain, right, I would have to find one longer. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Nope, can't find one longer. So 8. So this is the chain. This is the branch. But remember, when we talk about numbering, you have to think about it, right? So when we were numbering this one, we want this branch in the lowest address. So that would be 1, 2, 3, 4, 5, 6. Yes, not 1, 2, 3, 4. It would be on 5. 2 or 5. What's the smaller address? 2. For this one, 1, 2, 3, 4, 5. 6, 7, 8, or 1, 2, 3, 4. What's the smaller address? 4. Okay, just something to think ahead. How many carbons are in the branch? 1, 2. What prefix would we use for the longest chain? 8 is oct. What prefix would we use to describe the branch? 2 is F. All right, so now look here. How many carbons are in the longest chain of this one? So again, we're going to assume we can go straight across, right? Unless we notice it different. So we can go straight across, that's 3. Can I get a bigger number than 3? 1, 2, 3, 1, 2, 3, no. So we'll use this as my chain, and this is my branch. How many carbons are in the longest chain? 3. How many are in the branch? 1. What prefix do we use to describe the longest chain? Well, 1, 2, 3 is prop, and 1 in the branch is meth. There we go. Okay, so now we kind of talked about it and I hinted at it. So how do we name a branched hydrocarbon? So we have to find the longest chain. So in this case, remember, go straight across first. 1, 2, 3, 4. That is the right answer unless you can find a longer chain. Well, I could go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 1, 2, 3, 4. So I can find a longer chain, so I can't use it straight across. Okay? So I could number it. So what part is the branch? It's this, right? And this is the chain. It's just not straight, and that's okay. All right. Now, in order to number it, I have to number it in a way that this branch has to be on the lowest number. Okay. So I could count this way, 1, 2, 3, and the branch is on 3. Or I could count this way, 1, 2, 3, and the branch is still on 3. So it doesn't matter. All right. So since the longest chain has 5, we will use pent. And since there's only single bonds, we end with ane. So we have pent-ane so far. But all we named is this piece. We got this thing. So we have to identify the branch. So I circled the branch, right? When we name it, we add YL. So this branch has 1 carbon. 1 carbon is meth. But it's a branch. So we say YL. Okay. Now we stick this branch in front of the name we already had. So now we have methyl pentane. Almost done, but not quite. We need an address, right? You can't just say, yo, go over to, like, you know, Franklin. Like, where on Franklin? You know, Franklin. No. Methyl pentane. Where's that methyl group? Give me a specific. And remember I said it didn't matter if we numbered this way or this way. It's all the time on carbon number 3. So 3 is the address. 3 says, hey, there's a methyl group on carbon number 3. Okay, so what are all these pieces say? Pent says I have a chain of 5 carbons. Ane says all of the bonds between the carbons are single bonds. Methyl says I have a branch with 1 carbon in it, and it's found on the 3rd carbon in the chain. So pent, 5 carbons, all single bonds. On the 3rd carbon, put a methyl. Methyl means 1 carbon. And then add until every single carbon has 4 bonds. And we don't have to write the H's. Okay. Now this looks like it's different, but if you look, it's really the same thing as this. Okay, because we could write it in a few different ways. I could have written it like this. Okay, is my chain, right? There's lots of ways, but this and this are ultimately the same. All right, so now we're going to name this. Whew, okay. Let's see if we can put all those pieces together. Are you ready? All right, so we need to find the longest chain. Well, if I go across, 1, 2, 3, 4. So 4 is going to be my answer unless I can find a longer one. 1, 2, 3, 4. Nope. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so my chain has 5. Which 5 are part of the chain? These 5. Okay. What is not part of the chain? This. So that's a branch. Okay. So let's look at my chain. How many carbons are in the chain? 5. What is the prefix for 5? Pent. Okay. These are all single bonds. How can I tell? What if I'm not sure? Well, when it's written in a condensed formula like that, you could draw out the hydrogens. So I would draw a carbon with 3 hydrogens attached to a carbon with 2 hydrogens attached to a carbon with 1 hydrogen attached to a carbon with 3 hydrogens attached to a carbon with 2 hydrogens attached to a carbon with 3 hydrogens. And all of the carbons have 4 bonds, so it's an alkane. So I know ane is my ending. So I have so far pentane. But it is not just pentane because I have a branch. So how many carbons are in the branch? 1. What's the prefix for 1? Meth. What do I add to the end of the prefix to say, oh, it's a branch? YL. But now what do I need? I can't just say methyl pentane. I can't just say go to Franklin Street. I got to say where. I got to give an address, right? So I had to figure out what number. So I could number it 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. What do you notice? No matter what, it's on 3. So my address is 3-methyl pentane. I have 5 carbons in a chain with all single bonds. And on the 3rd carbon, I have a methyl group. That means 1 carbon. Okay, let's look at this one. Name this one. So I'm going to pretend or hope or start with that the longest chain goes straight across. So that's 1, 2, 3, 4. Can I find a longer chain? 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Nope. So 4 is the longest. So this is my chain. This is my branch. Okay. Name the chain first. How many carbons? 4. 4 is bute. Do I have any double bonds, any triple bonds? No, I do not. Ane. So this means 4 carbons connected with all single bonds and then just filled in with hydrogens. Is that the end of the story? It is not. I have a branch. My branch has 1 carbon, so that's meth. What do I add to the end of meth to say, hey, it's a branch? YL. Okay, so I put methyl in front of butane. Am I done? No, you can't just say, go down the street. I got to give an address, right? Address. I need an address. So I could number the carbons 1, 2, 3, 4, or 1, 2, 3, 4. Which way puts the methyl group on the lowest number? 2. So 4 carbons connected with all single bonds. I have 1 carbon attached as a branch on carbon number 2. And there we go. Okay, so we're going to try to tie everything together. Now you're definitely going to try this on your own. Here is an example to guide you through it. But if you are still confused, then please watch this so that hopefully it makes more sense. Okay? All right, are you ready? So this one. Draw the structural formula for octane. Okay? Oct means how many? 8. So draw a chain of 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. All right? Ane means they're all single carbon bonds. So that means just fill in the remaining spots with hydrogen. So every carbon needs 4 bonds. So this carbon has 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I could write the H's at the end like this one has it, but I don't need to. This is it. Like, make your life easier, right? So how many carbons? 8. What is the molecular formula? C8H12. H. So how would I figure out the number of H's? Well, this is a bond between a carbon and a carbon, but this is a bond between a carbon and the hydrogen I don't have to write. So I'm going to count these lines at the end that aren't attached to anything else because I'm assuming they're H's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, what is the empirical formula? Can I reduce this? Yep, divide them both by 2. And what is the condensed structural formula? So I go carbon by carbon and I say everything that's attached to it. C with 3 H's attached to a C with 2 H's, attached to a C with 2 H's. That's where I am right now. Attached to a C with 2 H's, 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 attached to a CH3. So let's count 1, 2, 3, 4, 5, 6, 7, 8. I do have 8 C's. Now I could write this a simplified way because what do you notice? I start with the CH3, I end with the CH3, and then I have a bunch of CH2s in the middle. So I could write CH3, CH2. How many of them? 1, 2, 3, 4, 5, 6, and then a CH3 at the end. So this and this are both correct. Okay. All right, this one. Draw the structural formula for butane. But, what does it mean? 4. So draw a chain of 4 carbons. Ane means all single bonds. So fill it in with hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. How many carbons? 4. Molecular formula, C4H, count. Remember, these bonds are attaching carbons, so it's the ones on the outside. I could, again, write the H's like up here, but you don't need to. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Molecular formula C4H10. Empirical, I can divide them both by 2. C2H5. Condensed structural, go carbon by carbon and say what's attached to it. CH3, CH2, CH2, CH3. I could shorthand it like I did this one, right? A CH3 at each end. And then the subscript for this one, instead of being a 6, would just be a 2 because I have 2 of them in the middle. All right, next one. Draw the structural formula for methyl propane. Okay, so let's draw this one piece by piece. Are you ready? So I'm going to start with the chain. The chain is going to be at the end. The chain says prop, that's 3. So draw a chain of 3 carbons. Ane means it's all single bonds, but I don't want to put them yet because I have this. Meth. What does meth mean? 1 carbon. YL means a branch, right? So I have 1 carbon as a branch on this chain. So if I put it here, okay, 1, 2, 3, 4, my chain becomes 4. So that's wrong. I can't put it there. All right. If I put it here, 1, 2, 3, 4, my branch becomes 4. My chain becomes 4, I mean. If I put it over here, same thing. So where am I going to put it? So I'm going to put it here. So this is the only place to put it. That's why it doesn't need a number. It doesn't need an address because there are no options. It's like only one house on the street. Okay, so I don't have to give you an address because literally it's the only house on the street. Now that's all the pieces from the name. So now I just add the lines for the hydrogens. Each carbon needs 4. 1, 2, 3. So this carbon just needs 1. 1, 2, 3, 4. And then don't forget the one on the branch. 1, 2, 3, 4. How many carbons? 4 total. What's my molecular formula? C4H. Remember, I only count the ones that the lines that aren't between carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Empirical formula, C2H5. Condensed structural formula would be CH3 connected to a CH, and then that is connected to a CH3. So this one's going to look a little weird, right? And then CH3 at the end. Okay, last one. Ready? Write the structural formula for 2-methyl octane. So start with my chain. Oct is 8. 1, 2, 3, 4, 5, 6, 7, 8. Ane means all single bonds. Meth means I have a chain of one carbon. Well, one carbon. The YL is a chain. 2 means it's on the second one. Now, it doesn't really matter if I count, oh, this is number 2 when I count backwards, or this is number 2 when I count forward. It doesn't really matter. It's just standard to put it on the going forward way, but it's not wrong if you had done this. 1, 2, 3, 4, 5, 6, 7, 8, and put it here. So I'm drawing 2 of exactly the same thing. Nothing else is in the name. So I fill in all the lines. So each carbon has 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Don't forget this one. 1, 2, 3, 4. And I'm going to do the same thing down here just so that you can see if you went through and counted them all, they would be identical. So how many carbons? Well, 8 plus this one, so 9 total. What's the molecular formula? C9H, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Empirical formula, well, I don't have anything I can divide them both by. So C9H20. Okay. And then what is the condensed structural formula? Well, I have a CH3. Then I have a CH connected to a CH3. And then let's count how many CH2s. 1, 2, 3, 4, 5. CH2, but 5 of them. And then I end with a CH3. So do I have the right number of carbons? 1, 2, 3, 4. And then I have 5 in here, so that's 9. Yep, I do. So there you go. That's the end.